Hey, what's going on, guys? Let's do this problem right here. The question is asking a proton moves with a speed of 5.0 times 10 to the power of 6 meter per second in a plane perpendicular to a magnetic field of 2.5 Tesla. Calculate the radius of its circular path. Let's see how we can do this. So we have this proton that moves in a circular path perpendicular to magnetic field. So let's say this is our proton. I use a different color. Okay, we have the proton right here moves in a circular path, and they are asking to find the radius, right? And we know that previously you may have used this equation: F is equal to BQV sine theta, right? Sine theta. And here the force is always going to be perpendicular to this one. Therefore, this one we can neglect this one. We know that sine 90 is equal to 1. So we can just write BQV. But the thing is, do we have all the information? We have, so here we are trying to find the radius, right? So we can't use this one for this one, but we have another equation. Whenever we have something in circular path, we have a centripetal force. That's Fc. Fc is equal to mv square over r, right? Therefore, r is equal to mv square over Fc, but we don't have the force provided. So what we can do is we can bring this equation and equate with this one. So BQV is equal to mv square over r. Therefore, r is going to be equal to mv square over BQV. And if you see, we have v square right here, v right here, we can cancel both, and we are left with mv over bq. Now let's go ahead and plug the values. First, we have the mass. So mass of the proton is 1.673 times 10 to the power of minus 27. That's not provided right here, but it's something you have to know, or they will provide you in the book, right? So this is the value. And then we have velocity that is provided right here. That is 5 times 10 to the power of 6 meter per second, right? And this is kilogram. And then we have the magnetic field, that's Tesla, that's 2.5 Tesla. And then charge of the proton. Charge of proton is 1.6 times 10 to the power of minus 19 Coulomb, right? So these are the units we have, and let's see how we can find the radius using this. I mean, we already plugged it, right? So if you plug this in the calculator, that's going to give you the radius. And if you plug this one, that's going to give you around 0.0209 meter. That's same as 2.09 centimeter. So that's going to be the radius of this circle right here. And the second question is asking, what is the energy of the proton, right? And when we know that whenever something in motion, that has kinetic energy. So we are going to use kinetic energy equation. Kinetic energy is equal to half mv square, and we know the mass already, and we have the velocity that's provided, and if we apply that one, that's going to give us the final answer. So half times mass, that is 1.673 times 10 to the power of minus 27 kilogram times 5 times 10 to the power of 6 meter per second square, right? And if you calculate this one, that's going to give you 2.09 times 10 to the power of minus 14 joule. So this is in joule right now, but the question is asking, what is the energy of the proton in electron volts? So to convert this one into electron volts, we know that 1 electron volts is equal to 1.6 times 10 to the power of minus 19 joule. and if you divide this one by this one, that's going to give us the answer in electron volts. And let's see what we get. And if you plug this one in calculator, that's going to give you 130,703 electron volts, and that's going to be the answer for this part right here, right? And maybe let's analyze the units right here. We want to know how did we derive the meter, right? So we have kilogram times meter per second, and Tesla is same as Newton per ampere meter, and ampere is same as coulombs per second. So instead of writing ampere, I can write coulombs per second, and instead of writing this one in the bottom, I can bring it to the top, so it's going to flip around anyway, right? So am meter. Okay, let's write this one on top. Instead of ampere, I am going to write coulombs per second. So per second, and then we have Newton ampere meter. So we have a meter also right here, and then what? We have a coulomb. So this coulomb and this coulomb cancels, and we have second square meter, and this meter and this meter. Oh no, they both of them are on top. That doesn't cancel. Okay, let's give the meter, and we have Newton in the denominator. And you may have seen Newton is, so we have this one right here, kilogram meter per second square. Newton is same as kilogram meter square, because F is equal to ma. So kilogram, m is mass, meter per second square, kilogram meter. So here we have meter square right here, meter square. This is kilogram meter per second square, and if you notice, everything cancels, and here also everything cancels, and we have this meter cancels, and we will left with meter, and that's how we derive this meter right here. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.